Well, hello. Let me introduce myself. My name is Casimiro Rino Kuswanto. People in Imaso usually call me Rino. On this occasion, we will discuss about one of physics topics, which is fluid statics. So let us begin our discussion. From the introduction. Before we proceed, do you know what the fluid is? Well, by the definition, fluid is a collection of molecules that are randomly arranged and held together by weak cohesive forces and by forces exerted by the walls of a container. To make it simpler, we can say that fluid is something that can flow. But by that definition, we can easily say that the examples of fluids are the liquids matter, like water, oil, and the gas matter, like oxygens or carbon dioxides. Then, if we focus our discussion on the mechanics of the fluid, there are two subtopics of fluid mechanics, which are fluid statics and fluid dynamics. In fluid statics, the fluid is at the rest state, so it doesn't move. While in the fluid dynamics, the fluid is in the motion state. It moves, or we can easily say it flows. On this occasion, we only emphasize our discussion on the static one. Then let us see the first properties of the fluid. First, what is pressure? To understand what the pressure is, let us see this figure first. When an object, for example, this cube, is submerged beneath the fluid, for example, the water, then the force exerted by the water on the cube is always perpendicular to the surface of the cube. So the six sides of the cube feel the force perpendicular to its surface. Then, if we change this cube with a device that can measure the pressure, for example, like this one, this piston or spring, then the water will compress the A surface until equilibrium, which means the inward force exerted by the fluid is balanced by the outward force exerted by the spring. The ratio of this force and the surface area is defined as the pressure. So pressure P equals F force per A surface area. The, the international system units of this pressure is Pascal, equals to Newton per meter square. Next, we will find out the relation between the pressure and the depth. First, we need to define a quantity called density as the mass of the substance per its unit volume. Um, yeah, in mathematical notation, it can be written rho equals to m per v. Then let's see the dynamics of this submerged box using the Newton's law. This box is static. It means it doesn't moving either in the horizontal or vertical direction. So we use the first Newton law, which is the total forces equal to zero in the vertical direction. Then we can say that the sigma Fy equal to zero because it's not moving, right? Then we need to input all the contributed forces on this box. First, we see the upward force on the bottom side of this box. From the pressure definition before, P equals to F per A, we can get the water force F on the bottom surface equals to P times A, the upward, this one. Because the force is upward, then the sign is positive. This one, this term. And then we see the second force on the upper side of the box. The upper box also feels the force down from the fluid above it. The fluid, which is the air or atmosphere. Uh, the air or atmosphere pressure is P0. So the force caused by this pressure is P0 times A. Because the force is perpendicular, so the direction is downward, perpendicular to its the box surface. So then because it's downward, so the sign is negative. And the last we'll see that because the force because of the mass itself, the gravitational force, or we can say the weight force. It can be found by m times g. If we put all of these three forces, we get this equation, and if we rearrange it and substitute the m value by the rho definition here, m is equal to rho times v, then m is equal to rho times a is the surface area, and h is the height of the box. Is so h times h is v, so rho v g. And if we move this term on the right side, then we get this equation. And if we divide all of this term by a, then we get this equation. From this equation, we can say that the pressure P at the depth h below the surface of the liquid open to the atmosphere is greater than the atmospheric pressure by an amount of rho gh. For your information, the atmospheric pressure P0 is equal to 1 atm, or in international unit 1.013 times 10 power 5 Pascal. Next, we'll discuss about the Pascal law. Again, this equation is known as the hydrostatic pressure. From this equation, we can also say that the pressure of the 2 points of the same depth and the same type of fluid is always equal to each other. Then, if the fluid in the container is given a change in a pressure on its surface, then all parts of the fluids will experience the same pressure change. This is known as the Pascal laws. One example of this law is just like this hydraulic press. When we press this first surface with F1 force, then the same then because the pressure must be the same at the same depth on the second surface, there will be an uplift force F2 to balance the pressure. In mathematical notational, it's just like this equation. The change of pressure surface, so F1 per A1 equal to F2 per A2. And if we move the F1 to the right term and the right side and the A2 to the left side, we get the F2 per F1 is equal to A2 per A1. Next, Let's proceed to the buoyant force and Archimedes principle. The buoyant force is on any immersed object, while the Archimedes principle states that the magnitude of the buoyant force always equals the weight. From this figure, we could see that the water level is increased from this to this um, by this small amount as we submerge an object. If we time this small change in the water level with its surface, then we get the volume of the water increased, which is equal to the immersed object volume. So the buoyant force can be written like this equation. Then we will see the two cases in using Archimedes principle. The first case, when the object is totally submerged. Again, we will review the dynamics of the object using the Newton's law. These are some constant that will be used. The fluid density, rho f, the object mass, m capital, and object density as rho 0. The buoyant force, just like before, um, is equal to the weight of the water displaced by the object. So if it totally submerged object, the buoyant force equals to rho f submerged volume, submerged object volume times the uh, gravity. And then we can find the weight force, Fg, of the object is simply m times gravity. By the density definition before, m we can find from rho 0 times v0. If we compute the b value and fg value, we get the net force, which form like this equation. Now, if the rho 0 is smaller than rho f, which means the object density is smaller than the fluid density, and from this figure we could see that the objects will move upward. Yeah, because it's smaller, so the sign will be positive. The positive, so it will move upward. But if the rho 0 greater than rho f, then it will be negative sign, so the object will sink. Next, on the second case, the floating object. In this case, the object is floating, so it is in a static equilibrium. It's not moving. So by using the Newton's law, the upward force must equal to the downward force. So buoyant force must equal to the weight force. This equation, and if we rearrange this equation, we can get this equation. Okay, that's all in this occasion. Thank you for your attention and see you on the next video. Bye bye.